Hi, so I'm Ben from Swing Swing Submarine, and today we'll talk about 2D. Swing Swing Submarine was founded in 2009 by William and Guillaume here. They made blocks that matter, and they released this on Xbox Live in the game, and then later on Steam. And it worked pretty well. So they leveled up. They hired two guys, myself and Jero, our artist. And we made this. We released this, Tetrobot & Co. We released this last year, and we switched to Unity to do this. And we released on Wii U a few days ago, and on mobile very soon. But really, all those games were just appetizers. Right now, we are making the game that these guys were dreaming of when they started the company. And it's called Seasons After Fall. It's exploration-based puzzle platformer. And you play this little fox that has the power to change seasons. So we'll just show the trailer real quick, the teaser. So yeah, slight delay. It only took 4 years and 2 games in between, but finally we're doing this. So 2D. There are lots of ways to do 2D these days. You got retro 8-bit pixel art, like Shovel Knight here. You got full 3D with 2D gameplay, like Donkey Kong Country. And our take on 2D is, well, obviously to use to do 2D in a 3D engine, which is Unity. We use perspective rendering. We don't have parallax or whatever. And we just place flat objects in a 3D space. And flat objects means no intersecting geometry. Everything is drawn on top of each other. So it's lots of sprites with big-ass textures. And instead of modeling, we use a lot of smart assets, which are like reusable assets, and that allow us to do all the composition in engine. We also use skeletal animation, which are puppets made of deformable sprites. And in general, our design tends to be very organic, lots of curves, no grids or tiles, and this applies to the level art as well as the level design. So this has been done before. As for myself, before joining Swing Swing Submarine, I was part of the team that made the UbiArt framework, and with that we made Rayman Origins and Rayman Legends. And later it's been used to make Valiant Hearts and Child of Light. So yeah, obviously Rayman was a big influence on our tech. We've also kept a close watch on Broken Age by Double Fine, in particular what they did with the characters and the lighting. And more recently we were very impressed by Ori and the Blind Forest. We don't know much about this game or it's made. We know it's a Unity game, but I'm guessing that they're doing a lot of things differently than we are. Yeah, and there are probably many more games. Finally, just to give you some context, here are some assets on the asset store that do things, similar things. You get Uni 2D that does lots of stuff. For terrain, you got Fur 2D. Apparently, there's something called Paper 2D on the Unreal Engine 4. For animation, you got Spine, Smooth Moves, Puppet 2D, etc., etc. We've evaluated some of these packages, but so far we're not using any of them. So let's show you some stuff. So this is our one of our basic level design tool. We use that for a lot of stuff. You just draw lines and curves, and you get a surface out of it. You've probably seen similar stuff before. Some people call it smart textures. Fur 2D as the terrain tool. But we call them carpets, because they cover surfaces. And they're really not limited to terrain, in fact. Earlier I mentioned the term organic, and it's very important because it drives a lot of our tech decisions. Also good to know is with the same spline data that we use for the graphics, we get the collider. Yeah, here you see it's colored differently. Like green is for ground, orange is for the wall. Here there's a wall, so the fox couldn't pass; he had to jump. So you get instant feedback for the level designer to know how it will work with the character controller. Yeah. Next tool is the ribbon. So it's the similar idea. You draw a spline, but instead of surfaces, it's specialized for linear shapes. So pipes, ribbons, trees, obviously. Anything you can paint in a line or a curve. So you see here with only 3 assets, the trunk, the branch, and the foliage, you can draw very diverse trees. A lot of our first level is done with just this, actually. And yeah, you get the collision, same stuff. You get the collision and the foliage as well. Although this time it's one-sided, so the player can jump through it. So how do you make those? Let's start with the ribbon, because it's sort of simpler. So this is the texture that the artist draws. You got a base, a tiling part, and a tip. And you just extrude the geometry on the curve and apply the texture. It's really simple UV mapping. Optionally, you can subdivide the tiling parts this way. This way, if you want a very small, tree, you only in 1 meter, for example, and it will match all the tiling match. So the base match with the obviously with the first tiling, but also with the second tiling, also with the tip, and same thing for the tip in the other side. So this way, if you need a small branch, then you take only part of the tiling, and if you need a bigger branch, then you take more tiling, and you still have the variation because it's 2 meters in total. And in between, obviously, we need to stretch, because since we have a base and a tip, we need to the extremities need to match. So we need an integer number of repetition in between. So yeah, that's the texture that on the left, the texture that the artist draws, but it doesn't work for the tiling part. You need to cover the full width of the texture for the repeat to apply. So we use an asset post-processor. I don't know who's familiar with asset post-processors. Okay, not that many. So basically, it's a hook you get every time you import a texture or refresh the texture, like you save in Photoshop, go back to Unity. You get a callback, telling you, hey, here's a texture, do what you want with it. And in this case, we cut it up and rearrange, so it works for our tiling. And yeah, here's a debug texture that we use. So you see, you get the base. 1 and 2 are the subtiles and tip. And another example with the foliage. So really the same idea. Okay. Yeah, and sometimes it's quite a flexible system. So sometimes we need to get creative. Like here, these trees are just huge. The base is 4K by 2K, and the tiling part is 2K by 2K. So if we put everything in one texture, we'll get lots of wasted texture space. So we can split each part into several textures, and it will still match seamlessly inside of just one geometry. And yeah, and we can also have variants, like the second base on the right is a third texture. Now, how do we make carpets? It's a bit more tricky. So carpets are made of a fill, which is just standard decomposition, triangle decomposition, and a mesh for the outline. So the fill texture is just a tiling texture, very standard. Usually it's not transparent. And once you have your decomposition, then your vertex coordinate becomes your UV coordinate. It's as simple as that. And if you use your world space vertex coordinate, then you get for free, you get matching. You can have, for your level designer, sometimes it's easier to cut the carpets in smaller parts, and they will snap. And even though I don't think we see much with this light, but trust me, the UVs match. Now the outline. Outline is a bit more tricky. So the basic idea is same as the ribbon. You just tile your texture along the geometry, and by default, we could see earlier that if you just take the length of your geometry, you will end up anywhere in the texture. So we can apply some snapping on the tile. So if we put a tile snap of 1, then we always want to use the full texture. So it will always end on the 2. And if we put a tile snap of 2, then it can subdivide. And so that's tile snap 1. And tile snap 2, it can subdivide and either on 1 or 2, depending on the length of what you're drawing. So again, this way you can have variety on what you draw. If you draw something big, it will be more varied. But if you need smaller platforms or whatever, then it works as well. And yeah, obviously also this simple outline here doesn't work well with corners. It gets deformed real quick. So introducing the 9-slice texture. This is very standard in any UA package, like Andy demonstrated earlier. You get part for the borders and parts for the corners, and you can stretch that. So we again apply our two tiles. We put 2 tiles on this to have more variety, and there you go. You can stretch your thing. And that's for what I call the outside corners. Yeah, the problem here I forgot to put fill, so the filling geometry, so it's not very obvious, but this is inside corners. What I call outside or inside is like if you have a ledge, you got a wall going up and then ground, so that's outside corner. And if you have a wall coming down and the ground, that's the inside corner. So you need 2 graphics for these cases. And you put it all together, you get the double 9-slice texture. which kind of sounds like a burger, but we call it the donut. And so yeah, the inside corners need to be different, but actually the borders don't. So here we just use the borders once. So that's the debug texture. Here's how it looks on a real texture. That's what the artist draws. So this way he's got everything in one place in Photoshop. And so yeah, everything needs to match. You have to tile everything everywhere. So it's kind of takes a bit of practice, but at least it's all in one place. And then again, UV mapping, very simple. You get your top corners, you get your top border, left border, bottom corners, bottom border, inside corners, and the right side border. And same thing as for the ribbons. This texture, as is not usable for tiling. So we post-process it, chunk it up, rotate the sides, put all the borders on top corners, and then bottom corners. It's important the way you arrange the corners, because they need to. Yeah, maybe it will be clearer on the real texture. Like you have white spaces at in some sides, and other sides will match. So you want to put the matching sides inside of the texture and the white space outside, so you don't have filtering issues, because the texture needs to wrap. Some fun with ribbons. We extended the ribbon system a little bit for a few gameplay elements. So here it's the spiral ribbon. So you draw your curve like before, and you get the nice ribbon with the collision and everything, and then you get a cursor, so you can unroll the curve. It unrolls in a spiral, and the longer you draw your curve, the bigger the spiral. It's all automatic. So again, you get one texture, and you can draw as many ferns as you want. The mushroom. So the mushroom is the same idea. You get a cursor to like unroll the mushroom from its bulb, and then we attach a mushroom at the tip of the ribbon. The mushroom is a separate prefab. It's fully animated. It's its own AI. And then the little bonus is that we bend the tip of the ribbon to match the bottom of the mushroom. And then we can also attach sub-branches to make like a mushroom tree, because who doesn't want a mushroom tree? And yeah, if we put it all together, this is what it looks like. So this is just what we call the slices. So this is just the playground, the level design slice. And pretty much everything you're seeing, except for the player and other characters, it's all sprites and these carpets and ribbons. So yeah, carpets for surfaces, closed shapes, and ribbons for linear open shapes. And then yeah, we get more slices for the background, foreground. This is how we compose the whole level. Get the foreground here, background 2, and then foreground. Very quickly, a word about animation. So for animation, we are using a sprite skeleton. And except each sprite is deformable. And yeah, we can do sprite swap on each body part. So you can get flipbook animation and all the animation itself is done inside of Unity. It's all in engine. That was very important to us to stay in engine, so we make sure we don't have rendering differences between what you're authoring with and what you're rendering with. And we can use mechanic state machines and extra. And so for animation, the artist just creates his character in a PSD layout, so one layer per body part. And then, as before, asset post-processor. So we use a PSD plugin that allows us to read the PSD itself, because by default, Unity, when you import a PSD, it will just give you the flattened texture. And we want all the layers. So we extract that to a sprite sheet automatically. So if the artist adds body parts or whatever, it's not a problem. And then we have to create the rig. So this is the skeleton itself. So you create bones. And then you say, OK, this sprite is influenced by these bones. And I'm going to draw the Bezier outline of the sprite. And then you can deform it, as we saw before. And now Guillaume is going to talk about rendering.
I think if they just turn it.
Yeah. I will take it from here to talk about rendering. So, as Benoit said before, we have a notion that we call slice. So it's some kind of layers. So every scene in our game are divided in 4 slices. So background 2, background 1, playground, and foreground. So it made the edition easier for the artist to place objects. And we will see that we can apply some effects on each of these slices. So the rendering in the game is done from back to front. So we're beginning to draw the background, which it's blurry. Then the background 1, then the playground, and then the foreground. So it's overdrawn because we refresh a lot of a pixel can have 4 colors, change 4 colors during a frame, so it's not so good, but we can limit that overdraw with Z prepass. So it's a little bit technical, but right now we don't use the Z buffer, but we can use it to limit the amount of overdraw. Then with those slides, we can put some effect on them. So here it's not super visible, but we can blur only one slice if we want. We can add lighting in only one slice, and it will not affect the other. So it's very practical to light the scene. Or we can say the light are globals, and we can add some distortion effects to draw the pulse, for example, you saw in the trailer, and to make some ice effect or stuff like that, because obviously we are going to change seasons in the game. And there is a distortion, but I don't know if it's visible. Okay. So after that, I will talk about lighting. So as Benoit said, we are using the carpet geometry to draw the light, because why not? It's already implemented, and it's allows us to have no texture. We can make light with no texture because it's all vertex color, and we can have any custom shape for the lighting. So the rendering is done in 2 parts. The light can have two attributes. The front light, it can be a front light, so it simulates diffuse lighting, so on the left of the screen. I don't know if you see anything. And then a light can have a backlight attribute. It's to simulate the Fresnel lighting or the rim lighting. And they use it a lot on the Mario Galaxy and stuff like that to highlight the characters. And then we combine those 2 lights, and we got the final rendering. So you can see on this tree, there is few details that are revealed by the rim light. So during the rendering of the scene, I will take the playground, an example, just take the playground slice rendering. So those 2 buffers on top are the backlight and the front light. So we are making some kind of deferred rendering, custom deferred rendering. It's our custom rendering engine on top of Unity. And then when we are drawing the objects, all the objects have two textures, one texture for the color and one texture for the rim mask. So that's those two textures, the two buffer. Then we simply combine the front light with the ambient color and the backlight buffer with the rim mask, and we obtain the final rendering. And then we can make some post-process if you want. So here's a close-up, but I don't know if it's very visible. So it was just the mix between the backlight and the rim mask to obtain the rim lighting, and then the same thing for the front lighting. And then we combine. So it's the final rendering. So in terms of post-processing, we don't use so much of them for now. We just use Bloom and HDR. So here is the scene when it's unlit, totally unlit. Then you apply the lighting we just saw before. So I don't know if we saw the variation, but and then we can put HDR on. So you see that near the flower, the lighting is brighter. And then we can put some bloom to make the thing more glowy. So, for example, on this tree, you see, I think, it's hard to see, but it's kind of hiding some atmosphere in the lighting. So the pros and cons of this lighting system is that it's scalable. It's some kind of deferred rendering, so we can add any amount of light we want because it's only some shape rendered. We have high blending control because we can position lights on top of each other and choose the blending, additive or semi-transparent light, and they will blend together. We reuse carpets, so it's a cool feature. We don't have to be so precise because, as you can see, the shapes it's a little bit a mess, but it just works because it's just lighting, so you don't see this buffer directly. It's just blended with other stuff. And if we need precision, we can render a sprite in this. If I want a smiley, I can tell my light, you render a smiley in this buffer, and it's cool. So the cons is that we need an extra buffer, the back mask buffer, for example, because we don't have normals in our geometry. But it's nice because designing normals in maps is not fun stuff for graphists. And the cons are it's hard to make a volumetric lighting. Here it's very flat, but it works because our game, our art is very compatible with this approach. The lights have no orientation right now. It's just a spot you put in the map. If we want orientation, we will add to make some extra buffer to store the orientation and say if an object reacts to this light direction or not. But it's feasible. And the slice decomposition have some limitation because we can't, when we put a light on the slice, it will affect the whole slice. But it's great because it's making the edition easier. So the next point about rendering is sorting objects. Before Unity 4.3, it was really hard to sort stuff because we don't have access to the order in layer or sorting order in the mesh renderer. So now we can do fancy stuff, and here to sort stuff, we have a render item that we put next to each renderer in the scene. And then we are computing a custom index to sort the list. So the most influence on the sorting is the Z position of the object. Then we have some kind of sub-order to be able to sort objects on themselves. For example, the fox is on the same Z, but these legs are before the body and the tail is after this. and so on. And we use a hash map to be sure that there is no conflict during the rendering when the two objects are on the exact same Z. And we sort the list that way, and we re-inject the result in the ordering layer in the renderer, so we can sort have total control on the sorting. So currently we are, like I was saying, we use renderer sorting order game object layer to put our different slice in the visible spot of the camera. Then we use a lot of stuff in the camera class, clear flags, target texture, color mask, and render, because we are forcing the rendering of the scene. For each slice, we say, now you put the object on the layer, then you take the camera and you make some rendering, and so on. So we are completely bypassing the default camera behavior. And some improvement we are looking for is the command buffer. It's a feature coming in Unity 5, so we are really excited about it. And what command buffer do is you have a list of commands, you give it to the camera, and you can say, draw this object, clear this buffer, set this render target, and so on. So it's just perfect for us because we will be able to have an even bigger control on the rendering. The cons stuff with this is that you have to make culling by yourself, because if you tell the camera to draw an object, it will draw it even if it's out of sight. And we will lose some cool stuff in the scene view, because obviously with the test we made with the beta, there is no picking anymore on the object you render with command buffer. So it's like the graphics .draw mesh function. You can pick object, draw with this. So it's a little tricky for edition. And speaking of edition, I will say some words about scene editing. So we made some work on the edition. So each of our scenes are divided in two parts. You have the managers. So all the managers are running most of the time in edit mode too, to be able to have the exact result in the game view. And all of our scenes are composed by the slices, like we said before, and a notion that we call the pages. So here you have, in the scene, you have some pages called debut, carrière 2, it's in French, sorry, cavern 2. So it's geographical place in the scene. So if you want to change your level design, you can grab an entire region and put it elsewhere. And it will work. It's very useful. And then you have some layer for each slices. So playground, foregrounds, background, and you can see the little prefix LA and SD, for example. It's for each people. So the level design will only work on the LD. The level artist will only work on the LA. And so with to cut the interaction between the objects, and we are waiting for some feature in Unity 5.1, which is a layer scenes. You can have multiple scenes, and you can edit only one scene at a time. So it will be perfect to work together, a lot of people on the same map, because right now we have to log the map. The level artist is working on it. Then he submits his changes. Then another guy can take the map and so on. So there is new feature coming. And I will have a quick look on the tools we made in the scene view to enhance the scene view. So we have this little window in the scene view. So the first combo box we made was the seasons switcher, because in this game you can switch seasons. So you want to see the effect in real time, and when you edit in the scene, you don't want to play the game every 5 seconds. Then the second tool is a camera synchronization between the scene view and the game view, because you want to see the result in the game without running it. So it's deactivable if you want to move the the camera without moving the game camera. So yeah, it's deactivated. And so you can have what you see in the game view is what you get in the execution of the game. Then you have a useful tool because we figured out that it was hard to select what we want in the game. For example, here I want to select the ground, and I'm selecting a fog because there is fog everywhere to have some ambience. So we made an extra tool to it's some kind of profile. It works with the Unity layers, and it changes the visibility of several layers to be able to select what you want. So here it was the ground, so I can edit the ground. And then, for example, if I want to select a fog, I will select the fog. And all the stuff you can tweak all the stuff, and we try to have direct impact in the scene at edit time to be able to make sure that the artists get the result you want. Another interesting tool is the camera filter. So we have some camera zone in the game, and the artist can have the camera constraints working in edit time. So in the scene view, the camera is trying to get farther, and we saw that it's not moving on the game view because there is a constraint on it. And we can choose some zoom factor, and the camera will adapt. So it's very useful to make some cinematic effects and stuff like that. And there is a lot of other filters. The more important one for the lighting is the light filter. So we use a lot of the little gizmo in Unity. It's very useful. You can customize your gizmo for every game object. So it's easy to, when you put the light layer, you see where there are lights in the scene with all the yellow dots. And then you can select and use the carpet system like Benoit showed you earlier. And I guess that will be pretty much it. So I like to make some really subtle lighting because I'm a programmer, so yeah. And another nice tool is the page slice selector. There is a button that can ping the slice we are working on. When you pick an object, it will automatically tell you in which slice it's situated. So when you want to add another object in the scene, you just have to click on one tree, for example, and you will see it's the playground. And then when you add an object by drag and dropping, we are overriding the drag and drop in the scene view, and we put the object in the good slice. So it's easy for you to quickly put object in the scene without have too much stuff to do with the hierarchy view. So and then there are other tools to help you to know if an object will be viewed in the camera or not, because sometimes with 2D games it's hard to see if some foreground will not be in the air when you play the game. So we have some extra rectangle shown by the arrow that will help you to know if this object will cover the whole foreground or not, or if will be a hole in the foreground or stuff like that. So that's pretty much it. There was some bonus, but I think we are out of time. 10 minutes. So just one additional slide. It's talking about the PSD plugin again. So for the lighting, it's the same as what Benoit showed before. The artist is only drawing, for example, the tree is drawing the front color, the front texture, and the back texture, the mask. And then we take it from here, and we put the black background in it. The artists don't have to care about filling with black, and we split the texture in compatible part with the rendering engine, and then we can use it. So it's really simple for the artist, and we are very PSD centric. So sometimes it's cool, but sometimes it's not, because you have to have a good naming convention, and sometimes the artists are not so compliant to naming convention. So if you have a question, I guess we have time for question.
Any questions?
Because everybody's asking when Unity 5 is released, when seasons will be released.
It will be released. I don't know if you. It will be released when Unity 5 is released. Now we are targeting 1 year development from now. So hopefully by the beginning of 2015, by the end of 14, we are 1 year from now.
Cool.
Hi. Do you have any plans to release the tools on the asset store? The ribbon and the
that's
carpet?
a good question because it was a lot of internal speak, and for now we just want to make our game. And if we feel that if we release those tools on the asset store, then we have to be a tool provider, maintaining the tool, make sure it works in all cases. So right now we are just focusing on our game and just making it work for our game. But when this game is done, maybe we will release it. But for now there is no real plan because we fear that when you sell something on the asset store, you have to maintain it. And for now it's not in our plans. It's just making a game with it.
Right. Thanks.
I'm just wondering, which version of Unity were you using to make those tools?
Right now is the 4.6 beta, and we are not using so much fancy feature in Unity, just render targets a lot. The rect transform, we use the rect transform for triggers and stuff like that. And yeah, it's basically all hacking all the way. And Benoit made some cool reflector. He used a reflector a lot. I don't know if you know reflector. So sometimes when all the gizmo you saw in the animation system, he reflected from other cool gizmo already made in Unity, just to see how it was working, and you can re-implement those. So yeah.
Okay, thanks.
Any more questions?
Hi. Have you had any challenges with texture compression, particularly for the various different forms of it on different platforms? And then, given you're very 2D heavy and image quality is very high, I'd like to know how you've dealt with that.
So in this particular game, we're far from shipping it. So yeah, on this particular game, not really, but from my experience, texture problems comes when you ship, because you're optimizing and oh my god, this is not gonna cut it. And so we've had lots of problems on the game, on the Tetrabot code that we're shipping now on mobile. But I'm a big believer in asset post-processor, so I never tweak any value manually. Every texture has to somehow go through a post-processor or other. So if I want to mass change 100 textures because I want to say, okay, no, I was using repeat for all these type of textures and now I'm not, then I'll change the post-processor and mass change everything. Does that answer it?
Yeah. For now, it's free memory and free for the artist. He can make anything he wants. It's cool. And then we prefer to have bigger texture and to have to crop them after that. Then we have to remake all the textures and stuff like that.
Actually, if we have some time, we can show you our post-processor pipeline. It's not very sexy to show, but I don't know. So yeah, by default, you import a texture in Unity and you get the default values. Depending if your project is 2D or 3D, it will not be the same default, but you don't have much control. And so you can script a post processor and say, okay, want this texture to be a normal map because the name contains bump. But I don't really like working like that because it relies so much on naming conventions and it breaks so easily. So what we've done is so you see here when I select a folder, I get you don't see. So yeah, when I select a folder, we've overridden the inspector. You can do that. You can override the inspector for folders. And you can say, I'll get one that's already configured, if I can find one. Why is it not? Okay, I'll get the bear. So yeah. Okay, so there's some rendering issue on the inspector. That's Rune's fault. I told him so. But anyway, so you see that the folder, there's some metadata attached to the folder that says, okay, all the texture inside of this folder are PSD sprite sheets. And so if I go in the folder, here I get the bare PSD, and it will automatically create the sprite sheet for me every time I save the PSD. And so this is like a profile of how you should import your textures. So we have way too many actually parameters on how we want to treat our textures. But then if we change this post processor and say, okay, now we want our sprite sheet to be packed tightly instead of with squares, then we can update all the textures in the project. And it will update the import settings and the textures themselves. So yeah, it's all folder-based with metadata on the folders. I would love to see that in the trunk, actually. Because the profiles you get, like the idea in Unity is if you go to advanced mode on a texture, it's kind of daunting. So the idea is you have these profiles, but you can't make your own profile. You can say it's a ribbon texture. Why do I say that it's a ribbon texture? In case I want to find all the ribbon textures in the project and change the compression or whatever. So we can't do that, but we can do that instead.